Okay, so waiting that the stream is starting and that I see the results on the test computer. Let's take a check. Still starting. So this session will be about how you can start developing on the RaspiBlitz. If you have a RaspiBlitz at home and it's running kind of the latest version, that's great. The question is then from there on, how can you modify the scripts, do your own services, and so on. So I will try to give you an overview here. So what you do is, let's move over to the screen. Let's take a look at the RaspiBlitz wiki or GitHub. So as you can see, if you're here on the landing page, that's the basic. I think you already saw that. What's most important is if you're working on the latest kind of version. That's, for example, on the release candidate for version 1.5. It's always good to change into the branch for it. For example, the v 1.5 over here. So then you're on the right code base. So normally what you do is like you can of course start to edit scripts on your directly on your RaspiBlitz if you want to try to stuff out dirty and quick. But the problem is then you lose all those changes once you do updates and so stuff. So the best way to really start developing on a RaspiBlitz is to fork the repo. So you would like clone and fork it over here, and then you have your own kind of repo address. And then you need to set your RaspiBlitz to that address. So for example, how you can do this, you find a section here in the FHQ. That's the FHQ from the RaspiBlitz on the GitHub. And how can I sync a branch of my forked repo with my local RaspiBlitz? So what you need to do is you log in into your RaspiBlitz. So for example, I'm here and then I'm going into that. So for sure, normally you see then the starting menu, but this is not what we want. We cancel this and we go to terminal. And if you take a look at the terminal, just of your home directory here from the admin user, you can see that there are a lot of files are in here. But those are already copied files. The link to the GitHub repo, the original files you find into this RaspiBlitz folder. So if you go cd RaspiBlitz, and you check out that one, you see that's here you find the kind of basic setup or files as you can see them. Where, for example, if I go back here, this you can see the same structure, the base root structure as on the GitHub. So at the moment, this if you're running on a installed RaspiBlitz version from the SD card or standard SD card, this code is linked to the RaspiBlitz repo. To change it to your forked repo, because there's where your changes are happening, you have to change the origin. So if you take a look, you can do this with a command like that. So you would now type into the command line git remote set URL origin and then the URL of your forked repo. And you can check this if you check the code, make a cd into .gat. This is a hidden directory here in the RaspiBlitz directory. You can see here are the files belonging to the Git repository, the Git management. And if you check in the config over here, use the nano editor. I know it's not everybody's choice, but I like it. Yes, I like it. And here you can see that at the moment the origin is still here on my machine. It's still the RaspiBlitz, but here you should see it changed once you set the repo, the origin repo to your forked one. So you can also maybe, if you don't want to use the URL over here, the command line over here, you can even change it in that file. That should be okay. So once you change that, you can go to the base directory, just to the home directory of admin, and use one command. Sorry, I'm a little bit slow because I have one hand here. because it's XX, the XX sync script that is always part of your home directory. And if you run that one, it syncs your repo you connected before, like with that on the RaspiBlitz, and copies all the important files into their right place. So this is the way how you can use an editor on your laptop, and you changing stuff in your forked repo. You make a commit to that repo, and then you sync it with this script to your RaspiBlitz. And after this, you can see the scripts in action. Normally, basic scripts should then be updated, and you can try them out. But if you modify something in the background running scripts, you maybe need to restart off the RaspiBlitz. So one little thing to add here is before we then look into the script's basic structure, is what you can do. You can switch between branches also. So for example, you can see here the branch it's normally synced is the version branch that you downloaded the SD card with. But if you want to change this to another branch, you can simply call the script, for example, and here tell it another branch name, for example, the master. So this way we would change back all the scripts now to the master branch, but I will put it back to the version 1.5. That's where I do my changes at the moment. Okay, so yeah, this is the way how you can very easily set it up and then make changes on your forked repo and then try it out on your RaspiBlitz. And once you see everything was working fine, then you can make a pull request from your forked repo back to the RaspiBlitz repo. And again, best would be also to, if you make a pull request, to make a pull request always to the developing branch. At the moment, this one is version 1.5 because this version is still in development. We are aiming for final release kind of in the next weeks, maybe hopefully next week. Okay, so now you know a little bit like how you can, when you modify code and fork code, how to get this on your RaspiBlitz and also back to the original project. But let's take a look what files we have here and where do you jump in if you want to modify something. Normally, this is just the base structure. The most important stuff is happening here in the home.admin. These are all, if you go into that directory, you find in the end all the scripts that are should be very similar. If I'm here in my home directory, those are kind of the scripts that get copied over this. And if you take a look at the ordering of the script, you see there are numbers before them here in this directory, or at least when you look further down, some weird prefixes that were just for ordering stuff. You can see those scripts that are here for you to see are based on the setup process a bit. Like those 001s are mostly stuff that runs in the beginning, or that you use, for example, the main menu. When you want to call a main menu, this is the script here that gets started. And then the setup stuff is over here. And then you can see a little bit, like by the numbering, the order of which scripts are running while during the setup process. Normally, I don't think you will do a lot of setup process because you will, I think, mostly work on bonus scripts or adding stuff at one point. But here, at least, you can see those are the main scripts. But not everything is in those scripts because those scripts sometimes just call kind of subscripts or functions, and those you can find in this config scripts folder over here. You can see them, they're ordered a bit like what they, in the area they do stuff. And those scripts you can use mostly a little bit like command stuff to change configuration. For example, if I take here the blitz.lcd script, if you see in the beginning it's a bash script. So yeah, you need to be a little bit familiar with bash if you're working. But if you're working on a server, on a Linux server or something, you should know at least most of the commands, and you should very quickly get into this kind of if-then structures that are kind of most of the things here. As you can see, such a config script is in the beginning is looking at what parameter that it has it got. Here it sees, oh, I got no parameters, and so I give in the beginning just a little info, print it out, and then exit. So for example, you can see here what this script allows you is to rotate the LCD screen. and some stuff like showing you an image on the LCD, or just hiding the image, or switching between the HDMI and the LCD screen. And so the idea is a little bit like here you get kind of the help structure, the help information. And then what the most scripts do is like they are loading with the source. They are loading kind of configuration information. There are two kind of information files. The most common you maybe know is the file RaspiBlitz.conf. That's always sitting on your hard drive at root. That's where your data is, and this is kind of your personal configuration, where every time also a config script changes stuff, it should kind of write its config state to here, so that on an update process later on it can be reconstructed. And if we take a look at this file, let me take more. I have to take this way. Here you can see stuff that's, this is how it looks like. It's just a file where there's value and keys, keys and value stores like written here. So, and all those, once you load this with source, those variables are available once this is successfully done. All this kind of values over here, I can test for them and later on check for them how it is. For example, like here, I can check if LCD rotate is not set. Like there's no string in there. It will be set into the config, and then in the end, it will be written back to the config. Here you can see the config switch is kind of rotating, changing something else here in the config boot, and then writing back into the config script a new value, kind of overwriting, replacing it here with the SED command. Normally you can just, basic stuff is like look how other scripts are doing it, and then just kind of copy paste at least the structure or the basic commands and adapt them for your need. Another config file over here is just the RaspiBlitz.info. It's not really a config file. It's more like where the RaspiBlitz is storing some information while it's doing stuff. This is more like a state it is in that is not persistent in the end. It will be reset on every restart. This is just where you can have some temporary state information. You don't, if you don't have to use it, that's good, but sometimes it makes sense. And also all scripts kind of load both files, so they have kind of a good overview of what is the kind of state the RaspiBlitz is in to get the information, and the other one to get the configuration here. Okay, so, and if you look further down, like here you can see sometimes the scripts see, oh, is there a package it's already installed that, for example, this script needs. So do some displaying on the LCD. You need this FBI command that the script makes sure that this one is installed when it's running. So if it's installed, it just goes by. So it goes deep down. And then it checks like here this command structure. So it sees like, okay, oh, the user gave me the rotate command, and then it checks if it's on or off, and it does the configuration like how it should be. And this is a little bit like how you can expand stuff. And to give you, for example, we have if we take a look at the challenges that we have for the hack sprint here. We have, let's take a look, it's at issues, and all the issues that are for the hack sprint are labeled here with hackathon. So if you just click the label, you just see the ones that are here for the hack sprint. And I will give a quick kind of overview now over the challenges that are here for the hack sprint. So maybe you have an idea where you like to get started. So for example, this one here is adding an SD card speed test before install. Maybe you saw it on the setup. If you're setting up a RaspiBlitz fresh, it tests the heating. So it makes a stress test on the CPU and sees how good your cooling is, and if this is kind of in an area that's still okay, or if the power has problems. And another thing that could be nice to add is checking if the SD card speed is in a kind of good way. So and one script that is doing at the moment the stress test is this one here, the config scripts blitz.stresstest.sh. And so, and if we take a look at that one, let's make this quick. Let's take a quick look into that one. You can see it's a similar build config script as you can find in the home admin config scripts and their Blitz stress tests. There it is. And yeah, and as you can see, a little bit like the same structure. Here it doesn't need to have the config because we're just testing stuff. And the idea is more like you can see it's doing some sys benchmarking. Like here, it's used this sys benchmark and installs this library or this package from Debian, and then it does its kind of test here. And what you can do is like extend this after it's done its stress test on the thing. It can also do kind of a short test on the SD card. For example, you can take a look here. There's some information here. There's a Raspberry Pi article to how to test the SD card. You can take kind of the commands that are mentioned in here, test them out, put them into a script. And one thing that it's always nice, it's the kind of idea how you give back the information. Let's see. Yeah, okay, here we see it. So in the end, what these config scripts should do is they should echo out kind of also variables. Like in the end, you make the test, you remember like if there were problems or not, or how fast the speed was, and then you make kind of SD card speed equals, and then you have to think of a good way how another script then, once it gets the results, can react to it. So there should be maybe two things, like one measured value and then a kind of threshold where you just say SD card is good or is slow or something, so that the other scripts can just check if there is a slow coming back from the script and then react and give the user then UI. So the idea is that this script is just doing the thing and then giving out the results, and another script that we saw in the beginning, like the setup scripts, can then just see this result and then show to the user a UI element saying, hey, your SD card is very, very slow. This is not a good experience if you continue here. So, for example, this was the SD card testing thing. Then we have a little bit, there's a very similar one, so I jump a bit. There is the, where was it? Yeah, for example, the test USB performance thing. So another thing that can happen and would be nice to do into the stress test script would be to test if really the hard drive or the SSD card is really connected to the USB 3 port. Because there are two types of USB ports at the Raspberry Pi 4. There are the USB 2, there are 2 slots for that and 2 slots for USB 3. And just like a typical beginner's error is like you put the SD card, connect your hard drive or your SSD to the wrong kind of port. And yeah, and if you connect your hard drive to a USB 2, it will be very, very slow, and maybe people wondering why it takes ages. So the good thing would be like also to test the speed of the hard drive and maybe then give a result back to the user if it's connected on the wrong port. I think this can take away potential errors that people would have during setup. So these are kind of the two things that could be added to a stress test. I think those are good starting points because there's very simple scripts, not too complex, that you can use. Then there is the adding spec to desktop thing. This is part of the 1.5 release for sure. And this is, if you like to work on that, you can also cooperate with the challenge group on the spec to desktop. And the idea is a little bit to try it out. It's a very new feature to have the spec to desktop app as an additional app, as an optional app you can install with the new 1.5 release candidate 1. So trying this out, get some experience. You can find a little bit more details always at the end of the issues. There should be some mentioning what would be nice to do during a hack day. For example, here, mark for hackathon sprint, test the spec to desktop on RaspiBlitz, give some feedback on that. So that would be awesome. And I heard that there is something still with the Tor connection. So testing it out, give that feedback would be awesome. So let's see what else we have on the menu for the hack sprint. There is the BatteryFS test. So Since 1.4 there is there's an experimental feature to use instead of using the hard drive format ext4, what is a standard Linux format for the hard drive, to change to a BatteryFS setup. So this is still experimental and there's still some testing needed. The good thing about the BatteryFS is you can make snapshots, so you can preserve kind of states and have easy kind of fallbacks for backups. For example, if your blockchain gets corrupted, then you can maybe jump back to the latest state from yesterday and just resume from there and not have to completely resync the blockchain to get rid of the corruption. Or you can, with BatteryFS, you can make RAID setups where you can have a little USB thumb drive that you can add to it, and then you have your important data gets stored into a RAID system where you have kind of two separate physical storing devices that the hard drive and the thumb drive where the same data is, and they can keep them each other in check. So these are the benefits that comes BatteryFS, and the idea would be test it first of all, and then if you really get interested, a lot of work was done to abstract the BatteryFS thing, because there's now a storage drive, there's a temp drive, so there's a lot of abstraction in there, and it's mostly done. I can show you the script so that you can have now where your starting point would be if you want to jump into the code. It should be Blitz data drive. Where is it? There is it. This is the kind of script. It's a bit long, but it's all the functionalities in there to format the drive. You can see format the drive to make it a fixed part of the setup through fstep, to add a RAID device and to remove a RAID device, to link all the special folders. So everything important is in here. Something can already still be extended for the BatteryFS, but also it's possible to add another kind of format for the drive. Like a lot of people is telling me that ZFS is a good choice, and there's an open version of ZFS. I think it's called ZFS. There's also another issue. You can maybe find details on that on the RaspiBlitz repo. And so if you really want to take the weekend and you know ZFS, for example, or OZFS, you can just go through the same structure here and just copy what we have for BatteryFS and give it a third option for ZFS. So that would be also nice. It would be a great challenge. So if somebody gets on that, would be very awesome. But just even to try out the BatteryFS is great. Next thing here is the KeySend. The KeySend is a new feature on LND, which allows you to send a little data with your payment or with your routing request. And the new release candidate already has a feature in there to activate this feature on the LND. It needs to be activated. Default is turned off, and to do some testing here would be awesome. On this challenge, you can also cooperate with the Send Many app. Over there, you can also cross-join the other chat room and see if you find people to check it out and test it here. So if you have a RaspiBlitz already with 1.5, or release candidate 1 on it, you can experiment with this and give some feedback on that. That would be good. This is the USB 3 testing, if it's connected to the correct drive. Then we have this one here. This is a little bit one if somebody is very familiar with LND, especially I will try to get back with Oliver on that one. Is there still something to optimize how to recover on-chain funds? A lot of people had some difficulties in the past. It's still possible with a workaround, but this should be fixed in a better way. There's one good thing, one service here that would be nice to have for the future of RaspiBlitz. It's a Watchtower service. So LND is providing already since the last version of RaspiBlitz the altruistic Watchtower function. So the idea is like, even if if my node goes offline and I partnered with somebody else who has running a RaspiBlitz or LND and running a Watchtower for me. So even if my channels, if I'm offline too long and somebody tries to cheat me on closing a channel, this Watchtower will watch my back. This would be nice if it would be a better, easy to use feature in the RaspiBlitz release. So to activate it, to make the config correct, there's already a tutorial from OpenORMS how to make it manually happen, and the idea would be now to turn it into a little bit more an easy to use feature for everybody out there. Then we have there was this one question. I think if somebody has a history with mining Bitcoin, there's always this question. Oh, I have a Bitcoin full node running here with my RaspiBlitz. Why is it maybe not possible to just connect mining hardware to it and also let it control my mining? So if you have a mining background and you have a RaspiBlitz running, so maybe this is something for you to check out. Even a prototype would be nice. It doesn't need to be a complete script, but at least some experience what worked, what kind of mining controlling software is, and how to configure it correctly. And even would be really awesome. There is the, because this makes sense with the RaspiBlitz decentralization of nodes, to also check out if there's some mining controlling software that supports the Stratum version 2 that has this job negotiation. This is related to the BatteryFS that Matt Corello was working on, to make it so that if you're mining in a pool, normally you mine in a pool because solo mining is very, very hard to do. But if you can mine also in a pool, but you kind of determine what transactions you add to your the block. So if you find a block, not the pool is telling you what transactions going in, your node is doing it. That would be awesome. So that could even make sense if you're having, for example, some power, green power available on your home, and you have some old mining hardware. Why not just let it running, and you always take kind of 10% of your transactions. You take zero feature transactions, whatever. Like you can then tell, you can be really decentralized the kind of control of what transactions get mined into it. I really like this idea. If somebody has time for that, would be very, very nice and awesome. And there's a little thing here to replace the public IP discovery. There's still a little bit a thing that could be better at the moment. It's important that the RaspiBlitz can see which public IP it gets from your IP provider. And to do that, it calls still an outside service. This is a very common service that's used at the moment. So I think it's not that we're doxing RaspiBlitz people here, but it's one external central service that would be nice to get rid of. There are already ideas how to do this. So I think Frankie was putting here some research into it, and it would be nice to go a little bit deeper there and maybe find the way how to get rid or to get a more decentralized way. And even maybe you try this one. If this is not working, you try this one. So this would be perfect to have it like a Blitz discover IP script, and then try different stuff out, what works, and if you can fall back to a better solution that works on that setup, it would be nice to have that. So that would be awesome. Also a good improvement. I think these are the features for the challenges for the hack sprint. I hope everybody got a good overview, and now will be available for a GT session where we can exchange a little bit more details and have questions on the single issues and challenges. So to get started there. I hope this was a good starting point. See you all in the chat room.